Ladies and gentlemen, welcome to an exciting video where we will delve into the specifications of the highly anticipated Chandrayaan mission. Let's explore the impressive details of this lunar exploration endeavor. Specification: Mission life, Lander Rover. The mission duration for both the lander and rover is 1 day, equivalent to down on a site measuring chemic site measuring low-tech coordinate section. Science payloads: The lander is equipped with several scientific payloads, including RAMBHA for radio anatomy, ChaSTE for surface thermo-physical experiments, ILSA for lunar seismic activity, and an ILRA for laser retroreflector array. The rover carries an APXS for alpha particle X-ray spectroscopy and LIBS for laser induced breakdown spectroscopy. The propulsion module houses SHAPE, a payload for spectro-polarimetry of habitable planet Earth. Two-module configuration: Chandrayaan consists of two modules, which accommodates the rover. With specification: mass: the propulsion module weighs kg, while the lander module, including the rover, weighs k. The total mass of the mission is kg. Specification: power generation: the propulsion module generates W of power. The lander module produces W winter solstice with bias, and the rover requires W of power. Specification: communication: the propulsion module communicates with ILSA, Indian Deep Space Network, while the lander module communicates with ILSA and the rover. Additionally, contingency communication can be established with the Chandrayaan orbiter. Specification: lander sensors: the lander is equipped with an array of sensors, including the laser altimeter, avoidance, Doppler velocimeter, LIBS, lander horizontal velocity camera, LVIC, microstar sensor, inclinometer, and touchdown sensors. Specification: lander actuators: the lander utilizes 4 reaction wheels with torque values of NEMS and MEMS. Specification: lander propulsion system, MON, comprising 4 enthrallable engines and 8 enthrallable engines, accompanied by throttleable engine control electronics. Specification: lander mechanisms of the lander include the landing legs, primary and secondary rover ramps, payloads, umbilical connector protection mechanism, and an X-band antenna. Lander touchdown specifications: during touchdown, the lander is expected to achieve a vertical velocity of no more than ms, a horizontal velocity of no more than ms, and a maximum slope of degrees. In addition to the specifications, let's dive into the objectives of the scientific payloads planned for the Chandrayaan. Here are the details: lander payloads, radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, RAMBHA, linear probe, ELP. Objective: to measure the near-surface plasma density of ions and electrons of variations over time. Chandrayaan experiment to test all properties of the lunar surface, particularly in the polar regions. Instrument for lunar seismic activity, ILSA. Objective: to measure seismic activity around the landing site and study the structure of the lunar crust and mantle. Laser retroreflector array. This passive experiment aims to understand the dynamics of the Moon's system, to perform qualitative and quantitative elemental analysis and derive the chemical composition and mineralogical composition of the lunar surface, enhancing our understanding of its characteristics. Alpha particle composition, ILSA, phi of lunar soil and rocks in the vicinity of the lunar landing site. Propulsion module payload, spectro-polarimetry of habitable planet Earth. SHAPE. Objective: This payload aims to contribute to future discoveries of smaller planets by studying their reflected light and assessing their potential habitability and the presence of life. These scientific payloads are designed to gather valuable data and insights that will advance our knowledge of the Moon, contribute to our understanding of the broader universe. Explorations. These specifications showcase the remarkable engineering and technological capabilities of the Chandrayaan mission. Stay tuned for more updates on this exciting lunar exploration venture.